Orange tracers hammer a T-90M in Stepov, Ukraine. In this 2024 viral duel, two 1980s-era Bradleys used 25mm chain guns to systematically shred the Russian tank's optics, turning the world's best armor into a blind paperweight. It was a masterpiece of grit, but for the Pentagon, it was a high-definition swan song. The countdown for the Bradley has officially begun. Earlier this month, the Army signaled the shift by requesting $547 million in its fiscal year 2027 budget to procure the first 19 pre-production units of its successor, the XM30. This isn't just a shiny upgrade, it is a systemic pivot. Major General Glenn Dean, PEO Ground Combat Systems, has been blunt. The Army has run out of room at the inn. The Bradley can no longer support the power or cooling required for 2030's warfare. This technological ceiling is currently breaking every legend in the inventory, from the sudden reboot of the M1E3 Abrams to the power-starved decks of Arleigh Burke destroyers. The XM30 is the first ground platform built specifically to break this wall. To understand the Army's aggression, we have to look at the silent killer of modern armor, the death of the mechanical platform and the rise of the digital host. The fundamental problem isn't that the Bradley is a bad vehicle, it is simply that the laws of physics have finally caught up with it. In military engineering, the Grim Reaper goes by the acronym SWaP-C: space, weight, power, and cooling. For a platform designed when high-tech meant a Walkman, modern warfare is a power-hungry nightmare it can no longer support. This technological ceiling is forcing a massive rethink across the entire American arsenal. The M1 Abrams was recently rebooted as the M1E3 because it hit a 73-ton weight limit, and the Arleigh Burke-class Flight the 3 destroyers have effectively run out of room for the electricity required by future lasers. The box is full, and the fuse is about to blow. The XM30 is the first ground platform built specifically to bypass this wall by prioritizing a digital host over mechanical hardware. At the heart of this shift is MOSA, Modular Open Systems Architecture. To understand MOSA, one must understand how disastrously closed legacy systems were. In the 1980s, the Army bought black boxes. If a vehicle needed a new thermal sight, the hardware was hardwired into the chassis with proprietary software owned by the contractor. Upgrades required stripping the vehicle to its frame at a depot, a process measured in years and billions of dollars. MOSA turns the XM30 into a software-defined warfighter by mandating standardized universal interfaces for every component. If the Bradley is a vintage VCR, the XM30 is a high-end gaming PC with open PCIe slots. This is the ultimate advantage for the 2026 battlefield. In Ukraine, jamming frequencies for FPV drones change almost monthly. On a legacy platform, adapting to a new frequency is an engineering miracle. On the XM30, it is a plug-and-play hardware swap. As Doug Bush, Assistant Secretary of the Army, noted, MOSA breaks vendor lock-in, allowing the Army to snap together a sensor from Company A and an AI processor from Company B like Lego bricks. The advancement isn't just about convenience, it's about the speed of relevance. Future AI-driven target recognition or autonomous drone teaming software can be pushed via data links or simple processor swaps. The XM30 is built to evolve at the speed of code, ensuring the digital ceiling remains miles above the crew's heads. To support a digital architecture like MOSA, a vehicle needs a power plant that functions as a high-output grid. This is the logic behind the XM30's hybrid electric drive. In the context of 2026 warfare, HEAD isn't a green initiative. It is a tactical survival requirement designed to solve the fatal flaws of the traditional internal combustion engine. In legacy platforms like the Bradley, the diesel engine is a dumb workhorse, oversized to handle peak loads but idling inefficiently most of its life just to keep the electronics alive. This creates a massive fuel tail that drains Army logistics. The XM30's head replaces this with a smaller, highly efficient diesel engine paired with high-torque electric motors and a massive battery pack. Instead of driving the wheels directly, the engine acts as an onboard generator to keep the batteries topped off. This battery-first approach delivers three critical advantages. First is silent watch. On a transparent battlefield where to be detected is to be destroyed, an idling engine is a thermal beacon for infrared sensors. Through its high-capacity battery storage, the XM30 can sit in a tree line for hours, with its engine cold, keeping its AI sensors and processors fully active while remaining thermally dead. Second is dash speed. Traditional engines take time to climb a torque curve. Electric motors provide maximum torque instantly. When an XM30 needs to jump out of a kill zone or accelerate behind cover, the batteries dump massive power into the motors for a burst of acceleration no traditional diesel can match. Third is the laser reservoir. By 2026, directed energy weapons have moved from the lab to the field. Shooting down $500 drones with $100,000 missiles is unsustainable. Doing it with a laser costs dollars per shot. However, lasers require massive surges of electricity. The XM30's battery pack acts as a giant capacitor, providing the high-voltage bursts required to power defensive lasers that 1980s-era alternators simply cannot support. As Undersecretary of the Army Gabe Camarillo noted in a recent budget briefing, HED reduces fuel demand by up to 20% while providing the power density to run the most advanced sensors in the world. The XM30 is essentially a mobile power grid that happens to carry infantry. This energy reservoir is the only reason the Army can successfully move to its next major requirement, a massive one-shot increase in primary firepower. While the hybrid drive is the heart, the XM9 113 50mm chain gun provides the teeth. This isn't a linear upgrade, it's a geometric leap. A 50mm shell isn't twice the size of a 25mm round, it is roughly 10 times the volume. The XM30 is built on a one-shot, one-kill philosophy. Developer Northrop Grumman designed the XM9 113 for standoff ranges that keep crews out of reach. While a 25mm gun is effective to roughly 2,000 meters, the 50mm engages targets at 4,000 meters and beyond. On the transparent battlefield of 2026, where drones spot you from miles away, you cannot afford to close the distance. You need to reach out and delete the threat the moment it appears on the digital map. The real advantage, however, is the intelligence of the ammunition. A 50mm shell is physically large enough to house complex electronics, allowing for programmable airburst munitions. During 2025 testing at Aberdeen Proving Ground, the Army demonstrated this lethality against the two hardest targets in modern war, drones and trenches. With a traditional gun, hitting a small drone or a soldier in a zigzagging trench requires luck. With the XM30, the laser rangefinder measures the distance. The MOSA-driven computer programs the fuse as the shell leaves the barrel, and the round explodes directly above the trench or next to the drone. It turns a near miss into a confirmed kill via a cloud of tungsten shrapnel. As Major General Curtis Buzzard, commander of the Maneuver Center of Excellence, stated, "The 50mm allows us to defeat targets in defilade. If we can see them, we can kill them, even if they are behind a wall." The trade-off is capacity. A Bradley carries 300 rounds of 25mm, the XM30 carries roughly 60. The Army is betting that 60 smart rounds that actually hit their mark are more valuable than 300 rounds of spray and pray. This firepower transforms the XM30 from an infantry taxi into a light tank killer, capable of shredding enemy vehicles from ranges where their guns are effectively useless. But a massive gun and a hybrid engine require a crew that can manage the data. This leads to the most debated change in the XM30, the disappearance of the third crew member. Technically, this is achieved through automated target recognition. The MOSA backbone synthesizes data from thermal arrays, acoustic sensors, and offboard drones into a single tactical picture. Instead of a commander manually scanning a tree line, the AI highlights potential threats with red boxes on the crew's visors. Brigadier General Jeffrey Norman, director of the Next Generation Combat Vehicle Team, noted, "We are moving the crew from operators to decision makers. The AI sifts through the noise. The humans provide the intent." The XM30 also functions as a mothership. From the cockpit, the two-man crew can control a fleet of robotic combat vehicles or launch tethered drones for a bird's-eye view. In high-risk scenarios, such as crossing a suspected minefield or a contaminated zone, the optional capability allows the crew to dismount and fight the vehicle via remote control from a safe distance. However, technical wizardry faces a stubborn reality check in the mud. Transitioning to a two-man crew eliminates the spare hands essential for the maintenance of a 45-ton machine. While AI can spot targets in milliseconds, it cannot help throw a track or perform field repairs, tasks that inherently demand 3 people. Furthermore, there is zero human redundancy. If one soldier is incapacitated, the vehicle is effectively out of the fight, becoming a blind tractor. The Army is betting that the AI's ability to prevent the vehicle from being hit outweighs the loss of that third crew member's labor. As the Soldier Touchpoint 3 evaluations conclude in the spring of 2026, crews from the 1st Cavalry Division at Fort Cavazos are providing the final verdict. The feedback highlights a classic dilemma. The crews are in awe of the AI's speed but remain anxious about the maintenance workload. One sergeant at Fort Cavazos summarized the sentiment. "The digital co-pilot is great for the fight, but I'd still trade a gigabyte of RAM for a guy who knows how to swing a sledgehammer when the tracks come off." This tension between digital efficiency and mechanical reality is the final hurdle for the 2 giants left in the ring. The competition has narrowed to a duel between General Dynamics land systems and American Rheinmetall vehicles. As of April 2026, both GDLS and American Rheinmetall are entering the final countdown for prototype delivery, with the first vehicles slated to arrive at Aberdeen and Fort Cavazos this summer. The GDLS entry is the pragmatic choice. Its greatest strength is its family tree. It shares significant logistical DNA with the M10 Booker light tank currently being fielded. For an Army worried about a 2-man crew's maintenance workload, this logistical commonality is a massive selling point. As one GDLS executive noted, "We aren't just building a vehicle, we are building a fleet that works together." American Rheinmetall offers a clean sheet Predator based on the KF-41 Lynx. It features a larger internal volume and an armor package designed for field-swappable modularity. While GDLS wins on commonality, Rheinmetall is betting on future-proofing. They are pitching the most digitally advanced armored platform ever conceived, built specifically for the electronic and physical chaos of the 2030s. The financial stakes are staggering, a contract to replace nearly 2,000 Bradleys. According to the FY 2027 budget request, the Army will spend the next 12 months grinding these prototypes into the dirt. By the end of fiscal year 2027, the Army will reach milestone C, the down select. One company will be eliminated, and the other will receive the green light for low-rate initial production. The target remains 2029 for the first unit-equipped ceremony. If the timeline holds, the first operational XM30s will roll into the motor pools of the 1st Cavalry or 3rd Infantry Divisions, officially starting the clock on the Bradley's retirement. This isn't just a vehicle replacement, it's the completion of the digital triad. By the early 2030s, the Army envisions the XM30 fighting alongside the M1E3 Abrams and swarms of robotic combat vehicles, all linked by a MOSA data cloud. It is a vision of an Army that sees the enemy from 4 kilometers away and deletes them with a single airburst before a shot is ever fired in return. The Bradley's performance at Stepove was a fitting tribute to the past, but the XM30 belongs to the future, a future where armor is a digital host, power is a high-voltage grid, and the most dangerous thing on the battlefield isn't a slab of steel, but the algorithm running inside it. The era of mechanized infantry is ending. The era of the digitized warfighter has arrived.